Hey, good morning, everybody. My name is Tony Andrews. Thank you for attending today's webinar, Advanced SQL and the Power of Rewriting Queries. Here's my email, tandrews@themisinc.com. This one's presented by me and Themis. I work for a company called Themis out of New Jersey. We're a training and consulting company. We train on a lot of different platforms. I spend most of my time on the DB2 platform. I do a lot of training. I also do a lot of performance and tuning consulting work on a number of different platforms, helping companies get some queries, programs, applications to run faster. So you're welcome to email me sometime down the road after this webinar. If you have any questions or you want a thought or opinion on something, I'll be more than glad to respond and will first chance I get. So if you have any questions during the webinar, I'll try my best to get to some of the questions toward the end of the webinar. You can submit questions by typing into the questions area of your webinar control panel. So you should have a control panel there. It should be a little arrow in a red box, if you want to expand the control panel, and you can send some questions in. Any questions that do not get answered due to time constraints, I'll try to take like maybe the last 5 minutes or so and see if there's any questions that maybe we can answer. Any questions not answered, I'll try to answer them via an email best I can, after the webinar is over. Okay. Let's look at the objectives of this webinar. This has to do with the power of rewriting queries. So one of the things that's going to come up, I hope a little bit more loud and clear for all of us, is better understand these relational database optimizers. The optimization portion of these relational database systems, they take our queries, the optimizer looks and sees what it thinks will be the best, most efficient way to go gather the data for our result set and bring it back. So we're going to look a little bit in more detail coming up here about when it comes to tuning queries and programs, what can we do, especially as developers, in order to get things to possibly run faster or to change. So that's one of the things we're going to spend a little bit of time on the optimization side. We're going to understand some steps to take when tuning queries. I find oftentimes when I'm out there doing some work, especially on the developer side, they may have something that's not running very efficiently, and they're not quite sure where to start. They're not quite sure the steps to take, where to start, what to do, as opposed to running to a DBA or a systems person to talk about something that's not running very good. So by the end of this webinar, you should definitely have some ideas on what you can do as a developer, or as anybody really, that empowers us to take a lot of steps that we can do without getting others involved. Another objective of this is you should come out a little bit stronger in SQL programming. We're going to see a few examples in here where we have 2, 3, 4 different ways to get result sets back, and we're going to talk about those in a little bit of detail, and I'm going to show you some little bit of output from and explain on some of these to show you that the optimizer is doing different things in order to retrieve the data just based on the fact that the SQL is written a little bit differently. So we've got some pretty good stuff coming up here in the next 45 minutes. So the material on this presentation is further developed in a couple of our Themis courses. We have a DB 1032, it's our performance and tuning optimization class. We have a DB 1041, Advanced SQL. On the DB2 side, these are probably 2 of our top 5 classes that we teach. They're for developers and anyone that wants to get stronger in coding and performance and tuning. 1032, you will definitely come out of that class knowing exactly what steps to take and everything involved that takes queries to run longer to get them to run faster. We get into to explain this in great detail. We get into a lot of rewriting of queries in great detail. DB 1041. It's all advanced SQL, and in that class we're going to touch on some of that here in this webinar, we look at sometimes 3, 4, 5, 6 different ways to get the result sets back by rewriting queries differently. That is both of these are classes that I think developers should definitely take, get a little bit more educated in, because the stronger we get in SQL, the better we can get in performance and tuning of queries. And everybody seems to be more and more thinking about how to get things to run faster because of saving a lot of IT cost on these mainframe systems. So links to these courses can be found at themisinc.com/webinars. You'll see some past webinars. You'll see the presentation for this webinar there. And again, there's my email. Okay, let's get into our material. So tuning approaches. So let's say you have a query, program, application. We're going to spend most of our time here at the query level, but if you got something that's not running very good, your result set's not coming back as fast as you'd like, what can we do? Where do I start? Well, the first thing that I always tell developers is change the SQL. If you can think of a different way to rewrite the query to get the same results back, then change it. So change it and let's retest it. If you have, if you're familiar with the explain features of these relational database management systems, you can explain any of your rewrites and see if they've explained differently and if the different paths that maybe the optimizer has chosen to go down. So even if you rewrite a predicate a different way, a predicate is one of the statements in our where clause. So by even rewriting a predicate a different way, maintaining the same logic, the optimizer may take a different path. So that's great empowerment for us developers. I mean, we're writing the code. We have the power to change the code, and by changing the code, oftentimes we're going to see can take the optimizer down different paths physically on how it's going to bring the data back for our result set. Second bullet there, redesign the program flow. I tend to find most developers, when it comes to coding programs where there's multiple queries involved, or batch type programs especially, they tend to code very procedurally. So instead of putting something together in a 3 or 4 or 5 table join with a subquery, they may break it up, and do some joining internally, or go down and perform an existence check, routine multiple times, for each row that's retrieved, as opposed to putting that existence check up in their main driver query. So oftentimes, I'll just go in and redesign the program flow. I call it procedural to relational kind of coding. Because every time out of these programs that you send an SQL statement to the DB2 or Oracle or SQL Server, the system to execute, people oftentimes call these trips to DB2. You're leaving your program, you're sending an SQL statement to execute. The more we send SQL statements to execute, typically the longer our programs run. So that's why we kind of think about coding more relationally. If it takes a 4 or 5 table join, code a 4 or 5 table join and don't split it all up in your programs. Gathering and altering statistics. Okay, when DBAs come in, they create our tables. The create definitions get put into the system catalog tables. On the DB2 side, they're all the sysidm.sys tables, sys columns, sys indexes, sys views, whatever they're creating. The definitions go into these system tables. Once the data gets loaded, DBAs come along and run some statistics jobs. Runstats, they call it in DB2. They run a Runstats job, and that updates these system catalog tables with data distribution information. Now, this is important because when we send a query to execute to bring back a result set, one of the things that the optimizer is going to do is going to look and see what tables are involved from our from statement, and it's going to go out and look and see what it knows about the table. How many rows are in the table? That's called the cardinality of the table. I mean, what DB2 does with something that has 50,000 rows in it is probably going to be far different than a table that has 585 million rows and has 120 partitions to it. So the statistics are very important. There's 2 main statistics that it looks at, and there's a lot of special statistics that we get into in our other classes, but it's the table cardinalities and the column cardinalities. Like one of the tables we're going to be querying against today is called the employee table. has the employee number, last name, first name, middle initial, hire date, the department the person belongs to. The statistics are going to gather up what they call column cardinality statistics. How many different employee numbers are in the table? How many different last names are in the table? How many different hire dates? How many different department numbers is everybody assigned to? And those come into play in optimization quite importantly. So in our production environments, the statistics are typically up to date. DBAs, they run jobs on a weekly, monthly basis. Our test environments oftentimes are not up to date, so we need to pay attention to that to see if our statistics are kind of out of whack, I could say, or haven't been run for a while. So if somebody comes in and inserts a lot of, loads a lot of data or deletes a lot of data, they should get a DBA to run another Runstats, so DB2 knows the amount of rows and the cardinalities at that point in time. We can change the physical design, the number of columns in a row, the clustering order of the data in the table, the indexes on a table, the column order of some of the indexes. And there's some physical design changes that can have a big effect on performance and tuning also. And the last bullet point there is system tuning. There's things at the system side that system parameters that can be changed, optimization levels like for DB2, LUW, some different things, buffer pool, designs. We're not going to get into any of that in today's class, but there are some things at the system tuning level that can be done. So from my own personal experience, when I go in and help companies get things to run faster, most of the time I change the SQL and I redesign the program flow. And I'd say probably 85% of the time that's what I do. About the other 15% of the time I'll gather and alter statistics, and I'll change some physical design. We'll tweak some indexes, add an index, maybe change them some. So we're going to spend some time today on the first bullet, mostly changing the SQL. So let's do a review of a few of the tables here. You're going to see in some of the queries coming up here. The tables that I'm going to show you here in the next few slides are from the set of sample DB2 tables that come when you load DB2, whether you load it on a Windows platform, a Linux, Unix platform, and a ZOS mainframe platform. They all come with a set of data tables. Now, these data tables have been around for 30 years. We continue to use these data tables in our training because when you go to any IBM manual and look up things on in the DB2 IBM manuals, all the queries that they show in there have to do with these tables. So it's kind of good to get familiar with these tables. We use them in our training classes because you're going to see examples of queries with these tables, even if you go out and Google things in like outer joins or nested table expressions or something. You'll often see examples based on these tables that have been around DB2 excuse me, for a while. So here's our department table. Department number, department name is a master table. There's a manager of a department. You can see some of the departments do not have managers. Those values are null. This is just kind of a partial list of some of the data. Let's go to the next table here, the employee table. Again, this is a partial list of the columns and rows. You have an employee number, the department that they work in, the last name. There's also first name, middle initial, the salary, the hire date. There's a lot of other information that comes on each row in that employee table. Employee number is the primary key. This is another master table. There's another table here called the EMP project activity table. And this comes up in our first example here. This is a table that if an employee is working on a project, they will have a row or set of rows down in this EMP project activity table. So it's a current activity table. So you can see employee number 130, they're working on project IF 1000 under two different activity numbers. Employee number 140, there in red, is working on a couple of different projects, some multiple activities within a project. And each of those activities have start and end times and hours associated with it and that kind of thing. So there's like a zero to many relationship between the employee master table and this activity table here. So if you want to know the people that are working on projects, you're going to look in this table. If you want to know the people that are not working on projects, you still need this table involved because it's going to be the people in the employee table that do not exist in this EMP project activity table. Okay, so let's go to our first example here. Provide a report of employees who work on project IF 2000. So we want to show employee number, last name, and salary. So in the notes there, like I said on the previous screen, there are some employees may not be working on any projects. So they're not going to have any rows down in that emp project activity table. Some employees may be working on one project, some may be working on multiple, some may be working on multiple activities within the same project. So in order to get the data back and the logic correct, for this example, we got two tables that are needed, the employee master table and then our activity table. So let's go, let's move on to this next page here, and let's see the first solution, okay? This is probably a typical way, the most common way that developers will go and get results for this particular type of output, but they write a join. So they just do a straight two-table join, where the employee number in the master table equals the employee number in the activity table, and the project number in the activity is IF 2000. So when they write the join, this is quite common, in these relationships between tables. So you have like a one-to-many. So we can see down in our results here at the bottom, we see the employee number 140, the last name of Nichols, comes up 4 times. But this isn't what the user wants. This isn't what we want in the program. We don't really care if an employee is down in that table working on 2,000 different activities on a project. I just want to know the list of people that are working on the project IF 2000. So because of the one-to-many relationship, we get duplicates back. So I can tell you from my experience, probably 99 out of 100 developers are going to take a join query like this, and they're going to come, I'm going to move to the next screen here, and they're going to throw the word distinct in there. The distinct, they know, gets rid of duplicates, okay? And they get Quan and Nichols out as in their output, which is exactly what we want. We don't want to see Nichols multiple times. So the one thing we need to watch out with the distinct, you can also use a group by to handle the duplicates. If you take the distinct out there and say group by e.emp no, e.last name, e.salary, that will also handle the duplicates. But the one thing we need to be concerned about with a distinct or a group by is oftentimes, in order for the optimizer to get rid of the duplicates via a distinct or group by, it takes the result set, it puts it into a work file, it sorts the work file, and then pulls out the unique rows. There's some overhead in sorting. Whenever we see a sort, in a query, that's kind of a flag to me. Do I need the sort is a question that always comes up. Does the query need the distinct or the group by or the order by or whatever is causing the sort? My second question when I see sorts is how many rows are going into a sort? Sorts are going to be as expensive as their size. If I have a sort that has a couple hundred rows in it, to get unique values out, or a sort that has, 2.5 million rows, there's going to be a longer run time on the sort process behind the scenes, the more rows that go in. So the one thing to point out here is distinct and group by do not always cause a sort, but they oftentimes do. And the only way we really know if there's a sort involved in handling these duplicates is to go to an explain for whatever relational database system you're on. And if you see a sort in there, it'll tell you it's doing a sort due to distinct. So when I see a query like this and I explain it, could be a sort going on, I think of some other ways I can get this data back without having to do a distinct sort. And let's look at the next screen here where we go to solution 2. This is an interesting one because the emp project activity table is needed for the logic of our query, but I'm not pulling any data from it. The only data I'm selecting in my output is just coming from the employee master table, the employee number, last name, and the salary. So that gives me an option. I can take that emp project activity table and I can move it down into a subquery. And we're going to see subqueries come in 2 flavors. There's a non-correlated subquery and there's a correlated subquery. And they oftentimes execute very differently, but the logic is the same. So if I take this query here and I write it like we have it here on the screen, I take the emp project activity table down and put it in a subquery, I don't need the distinct or the group by, because the logic is that an employee number in this list of employee numbers that come out of this subquery. If it happens to be in that list multiple times, it will still only show up one time. It doesn't get executed like a one-to-many join relationship here. So we could take this example here and we can move it down into a what they call a non-correlated subquery. So this is a two-step process behind the scenes. The optimizer will take that subquery, it will execute it, take the list of employee numbers and do one of two things. It will build a list for the in predicate that is a part of, or it'll put the employee numbers into a temporary table and feed that table to the employee master table in a join process. All right? So there's another way to get the same solution that we're looking for. Let's go to a next example, or the same example one, the next solution, solution number 3. We could take, instead of coding that in non-correlated subquery, we take it and we write it as an exist subquery, correlated subquery. So it's a correlated subquery because when you look down in the where exist, the select there's a join predicate where e.empno equals ep.empno. So this, again, is another way it's going to get us the 2 rows, Quan and Nichols back. But this subquery, because of the join predicate, is going to get executed multiple times. So one of the things that we go over in some pretty good detail in our advanced classes is, we need to figure out how many times this subquery is going to get executed. Well, in this case, we don't really have any filtering logic from our outer query. So for every employee number there is in the emp table, it's going to feed that down to the subquery and check for an existence. The existence subquery throws a flag back up, yes, it existed, or no, it didn't exist, and that determines whether a row gets written out to the result set or not. So again, as we kind of walk through and talk this through, we're seeing, the join, which could have the duplicates. We have the non-correlated subquery. We have the correlated subquery that are all bringing us back the same result set, but they're all behind the scenes operating very differently, okay? Let's go to the next page, solution number 4. This is one that I still see out there in application code from time to time. This is typically the least efficient of the ways to check this kind of logic, where you're checking where 0 is less than, and you do a count function in your subquery. Now there's a join down in our subquery, so we have a correlated subquery going on there. So that means that subquery is going to get executed a number of times. In this case, for each employee number. But the logic is not very efficient in that it doesn't really matter whether an employee is down in that table under IF 2000 one time or 1,000 times. All we want is a list of the people that are working on that project. And we don't care how many activities they work on, just are they working on the project. So to go into a subquery that's going to count up all the different rows where an employee exists in that emp project activity table and then compare it to 0 is rather inefficient. But the logic works. And this is still some logic that I see oftentimes when I get out in application code. So let's go to this next screen here to kind of sum up these 4 different solutions. The distinct DB2 may sort the final result, sort the final result set to eliminate the duplicates. In the non-correlated subquery, the subquery executes once, puts results in either a list or a table to feed the outer query. The correlated subquery, the subquery gets executed multiple times, executing for each unique employee number. And the count counts every row where the employee number exists in the emp project activity table and compares to 0. Very inefficient in that case because we don't really care how many times somebody's down there. We just want to know if they're down there. So in the existence check, for example, the first row it finds where that person exists, it stops and throws a flag up. It doesn't even go try to see if it exists in other places in the data file. So what I did on these 4 queries on our Themis system is I took those 4 queries and I ran them through an explain. Query 1, 2, 3, and 4, the query numbers. And I outputted a portion of what we get out of the explains. Now the explains will give us, are there indexes being used? What's the join type? What's the join order? What sorts are involved? Gives us all those details. And there's another portion of the explain output that gives the guesstimate on cost. Okay, and it comes from this DSM statement table in DB2. So the point I want to make here on this screen is you can see query number 1 has a couple of different costs that comes out from DB2. Now remember, these are guesstimates from DB2 on how long it thinks it's going to run this query to bring the result set back. One cost comes out in milliseconds, and the other cost comes out in a mainframe ZOS gauging called service units. So the point to be driven home here is, as we look at each of these different queries, we're seeing different costs come out. We're seeing different costs because there's different things that DB2 is doing behind the scenes on each of those queries to bring back the data. You know, as we walk through each of them, you know, we kind of understand a little bit more of how some of this SQL operates. So in this particular example, it looks like query number 2 and 3, which came out with the same costing, that was the correlated and non-correlated subqueries, looks to be like the most efficient way that DB2 thinks is going to be to execute this query based on the data and the table structures and the indexes and everything involved. The last one, as you can see, that where 0 is less than select count star, comes up as the most expensive one. Okay, so this is the key to query rewrites to me. We rewrite a query a different way. Oftentimes it sends the optimizer down a different physical path on how it's going to get to gather the logic needed for the rows needed, and that in itself could make for like some different costing. So the question that typically comes up from developers is like, well, just tell me which way is best. Well, there's not always a best way. You know, the answer is typically it depends. In this particular example, the correlated and non-correlated subqueries seem to be the better choice by the optimizer. But the join, if there's not a distinct or group by sort going on, in other cases could be the better choice. So it depends on the amount of data being filtered. It depends on the indexes. It depends if sorts are needed via the distinct or the group by. There's a lot of factors that come into play here. So there's not a silver bullet here that this way is always better than the other way. So I know when I'm on projects and get involved in some big projects, you know, I'm big on program walkthroughs, and I'll tend to get all the developers together and make sure they know how to code an in and an exist and an exist back to an in, so that when they come to a walkthrough and I see an exist, I'm going to ask them if they've tried the in. If I see an in subquery, I'm going to ask if they tried the exist subquery. And then I'm going to sometimes go back, have you tried it, even a join? Did you get the duplicates, and was there a sort involved? So we want to go forward with the most efficient queries. Okay, let's look at another example here. This is a table that we don't actually have this table in our Themis system. This is not one of the sample tables. This is a table that we kind of put together just for our advanced SQL class. Provide a list of employees that major in both math and computer science. So this is a very common table design, you know, where companies will have a row for each product that a customer bought, you know, either in fast food or retail industry. This is a table where you have a row for each major an employee is majoring in at a particular like university. So we want a list of employees that major in both math and computer science. So I need to find the employees that have a row in there under a major of MAT and a row in there under a major of CSI. Now you can see there's employee number E2 in that table that only majors in MAT. So we don't want that person to show up because they have to have a row for each MAT and CSI. Okay, let's go to our first solution here. Group by halving logic. We could select from that table where the major is in MAT, CSI. We group by employee number, and then we put a halving clause that says, out of those groups, give me the groups that have a count equal to 2. There's going to be a group for employee E2, but that's only going to have a count of 1 because they're only in one of those majors. So this is one that behind the scenes DB2 is going to take, gather up the rows that major in math and computer science. It's going to group each of those into its own employee number groupings and then have a count associated with it. You know, the group by and the halving is a two-step process in SQL. The group by does all the groupings. Oftentimes there's a sort involved in the groupings. The halving logic puts logic against the groups. Okay? So that's one way to get the solution back. Let's go to the next screen here, solution number 2. We can code what we call a quota query, where we're saying where the number 2 is equal to, and we're going into this count logic. Now we showed a count logic, in the previous first example that ended up not being very efficient. We added it in this one because it's just another way to get the data back. And so we have where 2 equals select count star from that emp major table, where the emp no equals the emp no. So we have a join down there. So this subquery is going to get executed for each individual employee number. It's going to count up. A lot of employees will be passed down there, and they'll have a count of 0 because they don't major in either math or computer science. So that's another way that we could get the solution back. Let's go to solution number 3. This is what we call a self-join in advanced SQL programming, where you list the table twice and you give it 2 different correlation IDs. Here's one as emp E1 as emp1 and as emp2. By the way, that emp2 would have to be emp2 altogether. That space really shouldn't be in there. So you say so we join by employee number between the 2 tables, and we say where the major in the first table is math and the major in the second table is computer science. Because it's a self-join, then that's going to get us those ones at both math and computer science. This is one of the things in our advanced SQL class and our performance optimization class that we spend some time on, what we call self-joins. There's a number of times in SQL programming where we have the same table in the from clause more than once. And why do we do that? And why do some developers have that? And sometimes developers look at a query and they'll see a table in there twice, 2 different correlation IDs, and they kind of wonder, is that a problem? Did they do something wrong? And the answer is no. Most of the time we need it in there for certain logical situations. And we go over those pieces of logic in a lot of our classes. Said, look, this is an example. If you don't do a self-join, you're not going to get the logic that you need. So here's like 3 different ways to get that solution back. These 3 different ways are going to optimize and gather up the data for our solution physically different behind the scenes. Which way is best? Well, the answer is it depends. Sometimes a join logic may be better. Sometimes a group by logic may be better. We have to look at the explain. We have to see what's going on in the groupings. We have to see what indexes are being used here in the join. We have to, it depends on a lot of things. So we write it differently. If you don't have the ability to do explains, you just write it differently and you retest it and see which one comes back the fastest. Okay, so example number 3. This will be our last example here. First solution, the problem is find the youngest employee in each department. So we got a user group that wants a list of the youngest employees in each department. We have all these employees, they're assigned to many different departments. So the youngest employee in each department would be the one with the highest birth date. The one with the max birth date is going to be the youngest one. So how do we figure this out? So we could come in, we could do a correlated subquery using the max function. We could go through the employee table, check each employee's birth date to see if it equals to the max birth date based on the department that they work in. So this is kind of like a self-join. We have the emp table in our outer query. We have the emp table in our subquery. We give it 2 different correlation IDs because I need to do a join where the department in my subquery E2 table equals the department from my outer query E1 emp table. This will get us a list of those. Let's go to solution number 2. This is what we can do now. This came up, I think, in version 7 of DB2. We can do what's called a row value expression. And we have a full select over on our subquery. In our subquery, it's an in subquery. There is no join predicate down there, so that's called a non-correlated subquery. That subquery is going to execute one time, and it's going to put those lists of max birthdays by department either in an in list, or it's going to put it into a work file to join to the emp E1 table in our outer query. So we can in our where clause here, we can in an in predicate, we can list a couple of columns. So give me a list of the employees that have their department and birth date in this list of departments with the max birth dates. Very different optimization, very different execution physically behind the scenes on getting these solutions back. As I take each of those and I explain those, you can see the costing came out way different. You know, query number 501, which I'm going to back up here. Query number 501 was the one where it was doing the correlated subquery, department equal to department. That one costed out much higher than the other one. Now I want to make sure you guys all understand that that does not mean, just go back here, that does not mean that this solution 1, query 501, is not ever a good way to code to get this type of solution, because sometimes it's a very good way to code. In this particular table design, DB2 said that that was going to be kind of expensive, and it puts a guesstimated cost more expensive than the other one. So the point I want to drive home again is it always depends. And what I tend to find in some shops sometimes is a programmer will write something a certain way, and one of the DBAs or somebody will get a hold of it, and it'll be very inefficient, and they'll go, I don't ever want anybody coding something this way again. And that's so what we should not be doing. It just wasn't good for that particular flow of data in those tables. But in other tables, the way they're designed and the indexes and everything, it could be very efficient. Okay. So we got these two examples here, 501, 502. They come out with different costing. And the reason I want to show you the costing is because if DB2 is doing things differently behind the scenes, physically to gather up our rows, is going to have different costs associated with it. So me, in performance and tuning, if I want to get something to run faster or run differently, I guess differently is the better word. If I have a query that I'm working on and the results are not coming back as fast as we would like, then I need to change the way that DB2 or Oracle or SQL Server, whatever the relational database system is, I need to change the way that they're going after the data. And we go back to one of the first screens that I had there. We had about 5 bullets. How can I change that? And one of the ways you can change it is rewriting the query a different way. That oftentimes changes the way DB2 or whatever the relational database optimizer is goes after the data. So there's times where I work on some queries and they're not running very good, and I'll rewrite them a different way and it runs worse. Said, okay, so it liked the first way better than my second way. Now see if I can come up with a third way. See if I can do something different. So you're not always going to get a query, go rewrite it a different way and get instant, faster results. But if it's already not running very good, there's a very high likelihood that if you write it a different way, it's probably going to run faster. We just need to test. Okay, so that's kind of the gist of our webinar and some of our examples here today. From both myself and Themis, I'd just like to thank everybody for allowing us to share some of our experience, some of our knowledge today. Again, here's my email. We hope you learned something out of this webinar today. More importantly, I hope you're a little more inspired to code with performance in mind. Next screen here. I know I've been involved in a lot of big projects in my career, and I'm often the project lead or the technical lead on these projects, and we definitely get the developers educated in different ways to do things. We definitely have walkthroughs because that's where we can learn from others how to do things better. And I've noticed that when developers get educated, good SQL programming standards are in place and program walkthroughs are executed correctly, incident reporting stays low, CPU costs do not get out of control, and most performance issues are found before promoting code to production. That is so true. That is just so true. And oftentimes management says, well, we don't have time for like walkthroughs. But well, we'll find time for walkthroughs on projects because we're going to minimize, we're not going to be in a reactive mode trying to fix things all the time once we go to production. A little bit of education. Me personally, I have a book, DB2 SQL Tuning Tips for ZOS Developers. Now, there's a lot of tips in here specifically to DB2. There's a lot of tips in here that relate to whatever relational database system that you're on. I kind of put this book together by working on projects and going into shops and looking at code over the years. And I just thought we needed something, developers needed something kind of simple. You know, a page or two on each topic tells them what to do, what not to do, steps to take. A lot of what we kind of went over today and then some. There's about 116 tips in that book right now. You can find that at IBM Press, Amazon.com, SQLtuningtips.com. And of course, Themis Inc. We do on-site and public virtual classes. We have over 30 DB2 courses. We have 400 IT courses. We have a great curriculum in all the relational database systems, DB2, Oracle, SQL Server. And we go over a lot of this advanced SQL programming, how to read explains, performance and tuning, and in each of those different platforms. And you tend to find, I've done performance and tuning on platforms other than DB2, and you tend to find the same thing when I go to these other relational database systems, as most of the time I just rewrite queries. I restructure their programs, redesign them, and then sometimes we tweak indexes and we tweak statistics. Very seldom do I ever do anything from the system side in order to get things to run faster, more efficiently. And again, the material in this presentation are very specific to a couple of our courses, DB1032, DB1041. There's a lot of workshop time in these particular courses, and as is in most of our courses. And those can all be found at themisinc.com. And again, my email, tandrews@themisinc.com. Okay? So let's take, let's see if we have a few minutes here for like any questions. Somebody mentioned there they bought the book. It was worth every penny I spent on it and then some. Well, I like that comment. Okay, so somebody mentioned here, after doing a Runstats, do you need to rebind to take advantage? That is a great question. You know, in running Runstats, you're improving the data distribution information that DB2 or Oracle or whatever the relational database system has. Okay, so the answer to this is it depends. Most shops, they will not rebind packages after they do Runstats on a weekly or monthly basis. Because what happens sometimes is when DB2 has a more updated statistics, most of the time it's going to pick either the same path or a better path. Sometimes, though, with the better statistics, there are certain thresholds that are hit. And DB2 will take a query that was performing well and send it down a different optimization path that it thinks is better, but in reality, it wasn't better. And it actually ran slower. And if they just do automatic rebinds after they do their Runstats, they could get some of those surprises. And management typically does not like surprises where all of a sudden a program is running much slower today than it was yesterday. I've seen some store procedure programs that that's exactly what happened. And the store procedure program was called, 10,000 times a day. And that store procedure program was responding in a couple minutes versus 5 or 10 seconds. And it was all because it got rebound. The statistics had hit a certain threshold. The optimizer took it down a different optimization path that it thought was going to be better. But in reality, it wasn't better. And it kind of brought the company to its knees for a while till the problem was resolved. So most companies will not do automatic rebinds. Although I can tell you in my experience, most packages and programs, when they're rebound with the better statistics, do take either the same or a better path. But they don't want to risk the fact that the optimizer may do a different path that runs worse. It's kind of like if it's not broke, don't fix it, is sort of the mentality, the thinking there. Okay, let's see. Are the slides available for download? Yes. themisinc.com/webinars. You can get a PDF of the slides today. Let's see, another question here. Would the where columns be indexable for example 3 solution 2? Example 3, solution 2. Let's see here. Let me back up. Example 3, solution 2. Yes, possibly, because with the row value expression. Yes, possibly. If the where department comma birth date is in, you know, this is that's a good question, and the answer again is it depends. If the output of the subquery is put into a work file and fed to the outer query as a two-table join, we'll most likely see the department index being used. There is an index on department number on that table. If it's put into the list, built as a list to fulfill the in predicate, we will probably not see an index being used. Kind of depends. You know, the optimizer's gotten smarter here lately. That when it looks at these in subqueries, it's going to look and determine how many values or sets of values are going to come out of that, and that kind of takes it down the road of, you know, do I put it in the list? Do I put it in a work file? What do I do with it? What are the indexes on the table? So there's a number of things that come into play there. So I guess the answer to that question is yes, could be using an index. Let's see what else. How does data get into the statement table? Do you run an explain? Yes, you do run an explain on this. It's interesting. In DB2, there's a new explain. There's a new GUI tool out there called Data Studio, which I'm sure many of you are familiar with. Data Studio requires, I think, as of version 10 and version 11 in DB2, like 28 explain tables. Okay. So in order to do explains, where you get a nice GUI visual explain out of the tool, you need to have all 28 explain tables created. If all you want to get is just some basic, is it using an index? Is it doing a scan? What's the join type? Are there any sorts? What's the costing? Then you really only need a couple of tables. One is called the plan underscore table, and the other one is called the DSN statement table. Okay? So when you go and do an explain, DB2 is going to look and see what explain tables are out there and load information into it. That's how DB2 and these relational database systems communicate to us. When we say, explain this query to me, what they do is they go through their optimization steps and they insert data into these number of explain tables. And then it's just up to us to query the explain tables. A lot of the GUI tools will automatically query the explain tables after inserts are done to them from the optimizer. So yes, that is just through a straight explain. As long as that table, DSN statement table, is out there, it will get loaded also. Okay, that kind of takes us to about our 45 minutes here. I really appreciate everybody coming into today's session. And once again, I hope everybody picked up a little something to learn from here. You guys have my email. I'm out on LinkedIn. I'm out there in my email. I get around to user groups. I speak at IDUG North America, European conferences. And I know myself and others at Themis will be doing other webinars in the future. So we hope to see you all again. So everybody have a great day, and thanks again for attending.